patience is a virtue. Have you guys done the patience virtue paper, seniors? Is that a thing anymore? The virtues and how you write about it? Oh, just kidding. Used to be a thing. Never mind. Trying to write a paper without using anything biblical about a virtue and explaining why it's good and why it's necessary. Interesting. Used to be a very interesting paper. Mr. Weitzel, you should go talk to him about it. Anyway, integrals applied. Integration is net change. Integration, we've done that, right? Antiderivatives, bounds. Derivatives backwards. So if it's derivatives backwards, couldn't it also be rates backwards? Because can't a derivative be a rate of change? So if integration takes rates and goes backwards, hey, what's that correction that you guys just did on that number 8 and you just turned in, or the test question from yesterday? What was that about again? Oil, yeah? What about oil? The rate that oil is being consumed, is it barrels per year? Barrels per hour? Barrels per year? There you go. That oil is being consumed. And then it says something about between one time and another time, how many barrels? How can you go from barrels per hour to barrels? How can you go from miles per hour to miles? How can you go from velocity to position? Oh, wait, I mean from rate to original. How do we do that? Integral. Because an integral from a to b says, hey, antiderivative of b minus antiderivative of a. And so if that's true, we can figure out, now the question on your test, both tests, had to do with just this simple subtraction. And a simple subtraction can be expressed as a simple derivative, the simple definite integral of the rate. But we're going to apply that so much more today, because we're not just going to talk about the change in, but the amount at. Ooh, not just the change in, but the amount at. If you guys are highlighting colored pen kind of people, if I were you, I would make a big deal about the at. If I were you, I would make a big deal about the at, the amount at, the number at. Because the crazy thing is, you guys, you haven't been exposed to too many AP questions yet. And you're like, yes, we have. We've had a semester and a half of calculus. Yeah, but I've kind of protected you just a little bit. If you have a kid one day, let's say poor little kid, poor little Johnny is like 2 years old, you going to go show him Silence of the Lambs right away just to throw him in the deep end? Oh, so maybe probably haven't been Silence of the Lambs. Okay, what's a good one more recently? What's that creepy one that you guys all like? There's so many. Give me a creepy one recently that everybody likes, even if it wasn't creepy to you. Oh, dear. Anyway, poor little Johnny, going to go and then they'd be like, here you go. Here's the real world. I mean, not the real world, but if he can get through this, he'll get through anything. Now, maybe at Magic Mountain one day, you'll take him on Goliath, like it's the first ride when he's a poor little shivering, I don't know, 6th grader, and be like, whew, if you can make it through this one, you can make it through any of them. That's what my sister did to me when I was in college. Anyway, help. Maybe, eventually, right, when they're 2, aren't you going to try to protect them a little bit? Aren't you going to care a little bit? Even if, well, some of you are like, I wasn't protected and I'm fine. Well, you probably have some scars from that. Or you're like, I was protected, too protected, but you were protected. Be thankful. Be thankful. But coming back, I've been protecting you a little bit from AP problems, but guess what this packet does? Well, I'm not slapping in the face because I'm here and I'm here to help, but it is going to make it a little bit more real. So, not quite in the packet yet, I don't think, but have the packet open, have the packet ready, because eventually we are going to get to packet questions, okay? But in your notes, integration as net change. If you were to talk to any Calculus AB kid that kind of remembers the AP, a lot of them don't, they block it out, but that kind of remembers the AP and you're like, what's something that you saw over and over and over and over again? Either they would say integration as net change, or they would not because they didn't see it. On an AP. That's actually the what? The highest score. You only need to basically get a 65%. Now some of you are like, ooh, I've been getting a lot of those. Sweet, I'm going to get a 5. Wait. I've been protecting you. However, have you been smacked upside the head every now and then with the fact that you are able to make mistakes. And that calculus can be hard. And they can capitalize on said mistakes by making them multiple choice answers. Okay. So the whole 65%, there's a lot of reasons for that. However, if you do not know how to look out for integration as net change, or even just integration in general applied, oh, you're going to be in so much trouble. So here we go. Let's see. A car moving with an initial velocity of 5 miles per hour in your notes. I don't think it's in the packet, in your notes. A car moving with an initial velocity of 5 miles per hour accelerates at the rate of, acceleration, 2.4 miles per hour per second for 8 seconds. How fast is the car going when the 8 seconds are up? And then how far did the car travel during those 8 seconds? For letter A, here's my question. Are they asking for, hold on, pause, motion? I'm starting here. I'm protecting you. I'm starting here. Motion. We've done it a lot. What are the 3 key concepts of motion? Key categories. Acceleration, velocity, position. Why did we do it in that? We could have done position, velocity, acceleration. Why would I never say position, acceleration, velocity? Why am I keeping velocity either before or after position, acceleration either before or after velocity? Why? Yeah. I derive to go from position to acceleration, or I integrate to go from acceleration to position. True? Okay. How fast? Speed. Yeah, I know. You drive cars, you push the little pedal and it goes. Come back. But technically, out of the 3, which 3 are how fast? We didn't say the word speed in our key 3. Not acceleration, velocity. Speed is the absolute value of who? Velocity. So if your brain can put together speed with how fast, wait a minute, should we know speed is how fast? Yes, as long as we're not making it an illegal substance. But coming back, speed, how fast? Hopefully that's where your brain goes. Speed, how fast? Speed is the absolute value of velocity. So how fast velocity, okay? Is this asking for, look at your forever card. There are 2 different things on this page, 2 different key things on this page. Either a change in or an at. A change in, difference between, that's a subtraction, or an at, an amount at, a speed at, a position at, a number of people in the park at, I don't care. Number of barrels of gallons, barrels of oil at. Either a change in or an at. Okay? Change in is going to be a subtraction. At is going to be one quantity at one time. What are they asking for in letter A? A change in or an at? Yes. How fast is the car going? Find V of 8. You guys agree? If we're measuring everything in seconds, find the velocity at 8. What's the velocity at 8 going to be? How fast the thingamabob is going either positively or negatively at 8. That's exactly what they're asking. So how do I take the information up above and find the at? Do you guys see that this is integration is net change? No, it's not. It's not position. But pause. Do I want an amount of something at B? Yeah. But instead of F, what do I want? V. I want V of B. Okay, fine. V of B is going to be V of A plus V of A. Do I need to know the initial to know the end? Do I need to know where I've started in order to figure out where I've come or gotten to? Yeah. So to find V of B, I need to know where I started, V of A, and then I need to know the change in. Hey, the change in that occurred. But how do I find the change in that occurred? I can't possibly think of all the different possible times, like infinitesimally small increments, 0 and 0.1 and 0.2 and 0.3 and 0.11 and 0.12 and 0.13 and 0.112 and 0.113 and there are infinitely many increments of time in between 0 and 8. I can't possibly find all the velocities, add them all up. But what can I do? Plug in the derivative, take the definite integral from a to b and say, hey, I don't have to add together all the different changes in. All I need to do is solve my definite integral of the rate, and I'll have it. Do I have the rate of velocity anywhere? Why did AJ just say A of t? Who is v prime? So v prime is acceleration. Plug in your acceleration, 2.4 t dt. Is this something that, wait a minute, who's v of 0? Uh-oh, I'm sunk. What do they say? V of 0 is, you're starting off at 5. The definite integral from a to b of a rate tells you the ultimate displacement or change in whatever quantity the rate of change is of. Well, unless they say something like the velocity at t equals 3 is, then I have to make my integral go from 3 because that will be my initial. So remember how they could give you clues to solve for c, for plus c? They could give you clues anywhere. It doesn't just have to be at 0. So whatever clue they give me is wherever I'm going to start my integral from, if that makes sense. Kiddos, can we anti-derive this? Here's the crazy thing. If they give you one of these, it might be a non-calculator integral. It might be a non-calculator problem you have to solve by hand, but guess what it is more often than not? A calculator one, because they're going to give you points for knowing what to do. They don't really care if you can do it perfectly by hand. They just want to know that you know what direction to go in. So guess what I want you to get out right now? Calculators, because we're going to be doing a lot of integrals in the calculator today whenever possible. Why? Because it'll only be calculator problems? No, but we've just covered 2 chapters on how to take integrals. For right now, we're just going to bask in the ability of using our calculator to solve the integrals and not just knowing the ideas about how we're using them. Does that make sense? So I'm going to erase this and say, yeah, we could have anti-derived. It would have been 1.2 t squared. Plug it in, plug it in. But I want you guys to go ahead and throw in an integral. Oh, no, my calculator doesn't know t. That's okay. Make it x dx. It doesn't matter. Just make sure that you have the right form. Whether it's a t dt, whether it's a theta d theta, whether it's a y dy, whether it's an x dx, it doesn't matter. You just need the correct expression, the correct bounds, and go. Someone get me an expression, not expression, a value for the change in velocities. Yep. Are there any more decimals, or is that it? Sweet. So therefore, we could just box it and be done, but just for sake of argument, I'm going to go ahead and add it, pretending it was a multiple choice or something like that. Oh my goodness, why can't I add? 81.8. Haha. What are my units? Ooh. Did some of you just get scared because there were miles per hour and seconds? Do we need to do dimensional analysis? No. Because this one, I had seconds and I had d-seconds. It's okay because I'm dealing with seconds and seconds here. I will go back to miles per hour. Everything is totally fine. Now if I had to integrate again with miles over hours, I would have to make the bounds hours. But since it was mile per hour per second and I had seconds, everything is legal. Everything is fine. How fast am I going now? 81.8 for sure? Yeah. Why? Because I was starting at 5, and in the course of this acceleration occurring over 8 seconds, my velocity changed by positive 76.8. Does that make sense? What does this solve for? The change in. The change in what? The change in the antiderivatives. And if I take the change in the antiderivatives and I add it to the initial, I'm going to end up at the final. That's position. Let's keep going now. Oh, there's a graph. But still position. Still being nice. Still protecting. The following is a graph of... Don't look at me. Look at the problem. Okay, the following is a graph of velocity. True? I'm hiding so you look at the problem. The particle starts at x equals 2 when t equals 0. Get down the important information. We have a graph of velocity. And we know a clue that x of 0 equals 2, right? Now technically the AP would have said something about the end of the trip, that the trip was in between 0 and 10 seconds. Let me go ahead and do a quick t is within 0 to 10. That's all that the graph shows us, so we're assuming that's our entire trip. Ooh. Find where the particle is at the end of the trip. As you guys are just getting down the info, can someone tell me, this particle, he's on like an x-axis, he's just going back and forth. Remember, we can only deal with linear motion, he can't go two-dimensionally. He's just going back and forth, this poor little particle. If he starts at x equals 2, I could even put a little picture and be like, x-axis, here's 0, 1, 2. Little particle starts here. What does this graph show me as far as the direction of the movement of the particle? What does he do for the first 2 seconds? He starts here. What does he do for the first 2 seconds? He moves to the, wait, that's something we're supposed to know. Moves to the right or to the left? How do I know moving to the right or to the left if this is velocity? Isn't that positive velocity, then negative velocity, then positive velocity? Moving to the positive velocity. Moving to the do you believe it or are you just saying it because you know it's not left? What are the signs of the velocities between 0 and 2? All the y's are positive y's. Positive y, positive y. And the y's are velocity is increasing and then velocity is decreasing. So he's moving to the right faster, 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 and then he starts to slow down. And he stops. How do I know he stops after 2 seconds? Then what does he start doing? So he speeds up and then he slows down. Then he stops. Changes direction and starts going to the left. How do I know? How do I know that he's going to go left and pass his original position and keep going left? He's going to actually be speeding up, speeding up, speeding up because velocity is decreasing and negative, speeding up in the negative direction. He's going to start going left really, really fast, and then he's going to kind of go like a cruise control. Then he's going to start slowing down. Then he's going to stop. How do I know he passes this guy? Because he's going to eventually start to go right, but couldn't he go left and then go right and never have made it back here? How do I know? Just looking at this graph really quickly, he goes right, slows down, stops. And then he goes left and he ends up over here somewhere, stops. And then he goes right a little bit. Did you hear it? It was perfect. Area, area. What is area? An integral. Integral, it's a change. Oh, how much he changes position to the right gets overtaken by how much he changes position to the left. Do you see it? So much bigger. He goes right for a time, but then he goes left. I don't know, over here somewhere. Then he goes right a little bit. And he stops, and he stops, and he stops. Okay. So, what are they asking at part A? Find where the particle is at. How do I put this in mathy terms? The end of the trip. Final position, good. And final position specifically, think about your forever card. Final position is going to be S of or X of, who's the B? When does the trip end? 10. Ha! Integration is net change. To figure out where it was at 10, I need to know where it was to begin with, plus how it changed. Of its rate. Whose rate? Position's rate. Who is position's rate? V of t. Where did it start? At 2. How long was it traveling? For 10 seconds. And what was its rate? V of, uh-oh. But I don't have an equation for v. Oh, no. I can't plug it in my calculator. I can't take an integral. You can't take an integral with your calculator, but you can find the integral because what is the integral? Not area factorials, but area with exclamation points. What do you have, or what are you able to find, because they are geometric shapes? Area. If I accumulate all that area, what Nick was saying, the positive change with the negative change, the moving right with the moving left, won't I know what this is? Add it to 2 and I'm done. Guess how many FRQs have some sort of geometric shapes in a graph? Oh, almost 1 every year. 2 plus. You're like, 1, well, that's not very much. 1 out of 6. 1/6 of 1/2 of the exam. Big deal. 2 plus. Area above is positive, area below is negative, true? Okay. I don't technically have to simplify because I'm hoping it would be a long answer. What's the area of a triangle, cool kids? 1/2. Base is 2, height is 3. Minus. Ah! Why am I doing minus? He's moving to the left. So my position of 2 added some spots, and now it's going to subtract a lot more spots. How much? It's a trapezoid. Could you guys do trapezoids because you're amazing? Yes. You also make this guy a triangle, and then make that guy a rectangle, and then make that guy a triangle, I suppose. But trapezoid, because I want you to remember that area formula anyway. So 1/2. Whatever's constant, which in this one is the height, and that's going to be a 1 and a 2 and a 3, times whatever's not constant, which would be the bases in this one, 1, 2, 3, 4, 5, and 1, 2, 3. But you could have done triangle plus rectangle plus, well, make sure you would have minused all of them because they're all negative displacement or to the left. And what else do I need? It's coming back to the right. So I have 1/2 base, which is 3, height, which is Now, according to all the work that we did, we said, or I said, he moves a little bit to the right, he moves way more to the left, and moves a little bit to the right. From just my quick analysis, I'm pretty sure he ends up somewhere in a negative position. But we could technically figure this all out and see exactly where he does end up. Not just how far right before he stopped, but how far left before he stopped, and then how far right before he stopped. And we could figure out and analyze that and discuss it however much they wanted us to discuss, but for right now, they just wanted the final position. So can't I just say meters, feet, miles? It didn't tell me. All right, fine, whatever. It's this. True? But what's letter B say? Can you guys still read it? Total distance? I don't get it. We just did that. Wait. Total distance isn't how far right minus how far left minus, it's not getting us at a final position. Total distance just says how far did he go, and how far did he go says how far right plus how far left plus how far right. Remember, the speedometer just adds up. Sorry, the odometer just adds up without caring what direction. So what am I going to do for total distance? Can't I just steal this guy? Oh, can I steal them all? Oh, struggle. Because this is how far he moved. I'm going to steal that guy, except what am I going to change? Yep, I'm going to do absolute value. And when I do the absolute value of each of the changes, what's going to change? The sign of this guy. Good. Because I have total distance, I need to say, hold on, wait, I don't care you're going left. All I care is there's a change in position. Dun, 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 dun. If you ever have to do total distance from a graph, you just say, oh, I don't care that you're negative. I'll just make you positive. Dun, 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 dun. How we doing? Are we getting the idea of at? To know where or how much, or the amount at, you need where it started plus the change in, and the change in is found from the definite integral of the rate. So what about this guy? It's not position anymore. It is motion. There's movement. Why? Isn't some tank draining? Yep. The water's coming out. Hey, isn't this like the oil being consumed? Because if oil is being used, and if oil is being used, it's being subtracted. Oh, water's draining out, the oil is being consumed. The bananas on the display at the grocery store are. The temperature of the biscuits just came out of the oven are going down. The tea in the cup is being consumed. What am I trying to say? The AP can make up any stinking problem they want, but the idea is the same, or the ideas are the same. The snow on the driveway is being shoveled. The miles to school are being bicycled. They spelled Karen that year with a C. Weirdos. The water, the funnel. Oh, that problem. There's so many tweets about that one. The fun thing is when you guys are taking your AP, I can see the tweets of the kids on the East Coast that just got out of their exam before you do. That's fun. Which they're not allowed to give details, but they are allowed to be like, bah, people on the are all crashing and dying. Funnel, who taught me that in calculus? Anyway, yeah, they're fun. The bananas are the most recent one. No, that was 2 years ago, actually. I forgot. Suppose that a tank initially contains 1,000 gallons of water and the rate of change of its volume after the volume. Huh? Wait, isn't water three-dimensional, guys? So aren't gallons volume? Isn't it filling a three-dimensional thingamabob? Oh, okay. So when it says volume, really it just means gallons, right? The rate of change of its volume after the tank drains for 5 minutes is V prime of t equals 0.8 t minus 40. In gallons, oh, that makes sense. Gallons per minute. Okay, volume. They were just trying to make me think I had to go do some volume formula. Okay, gallons per minute. How much water does the tank contain after it's been draining for half an hour? You know what a lot of kids make a mistake of right at the very beginning? Position, x of t. Velocity, v of t. Acceleration, a of t. Water. What do you want to make water? Your call. I don't care. Who do you want him to be? F of t? But there might be more than one. B of t, boring problem. W of t, it's water. Z of t, because, oh, we never use Z. Cool. Does it matter what you label? No. You can just say Z of t is equal to, well, wait. We don't know what Z of t equals. Okay, fine. Well, what are we supposed to be finding? Find Z of... What's it say? Half an hour. Why are you telling me 30? Because they said somewhere that it's measured in. Got it. Find Z of 30. Sweet. Z of 30 is equal to, when does it start draining? Well, I guess it's 0, but did they give me what was going on at the very beginning? Oh yeah, they do, at the beginning. So let's start at 0, because they tell me initial, 0 to 30. I know where it was at the beginning. I know it's going for 30 minutes, and I hope I know the rate of Z. Wait a minute. Didn't they give me a derivative? Oh, I went off being like water. I don't know. Let's just call them a variable, Z. W might have made more sense, but that's okay, Z. But then if I look at my problem, oh, hey, they gave me the rate. Oh, they called it V. Okay, fine. Okay, fine. They told me what to make it. V is for volume, not W for water, or Z because Nick likes the letter Z. Instead, they said, let's use V. Okay, fine. Fine. That's okay. We can readjust. Does it really change much? No. Now it's at least seamless with what they told us, and they're not going to be like, Z, where did that come from? But in other problems, they might not give us the variable, so we can make it whatever we want. In this one, they gave us the variable. Volume, okay, whatever. It's the water. It's the gallons. Look at them being confusing. Okay, so what do we do? Is anybody going to their calculator yet? What do we do, Nick? Yeah, we could anti-derive the formula. Or remember, hold on, if this is an FRQ where you can use your calculator, technically, I don't want you doing that. All I want you doing is writing it to be like, hey, I know what I'm doing. Filling in 1,000 because you're like, I know how much it started with, and then plugging it in and getting me a decimal answer and being like, done. Calculator FRQs, you don't solve anything by hand. You just express what you're about to put in your calculator. And don't you dare ever be like, in my calculator, I went and found function integrate. I hit all the buttons and I put this in. No, no, no. They don't care. They don't care. They just want the answer. They assume you know how to use your calculator, and believe me, they know how to use their calculator. You do not need to teach them. Okay? Get the expression, throw it in, get me a decimal. How many decimal places for AP? Always, 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 and forever. Okay, what do we got? 160? Ooh, this is 160? Oh. Oh, because it was draining out. This makes sense. The story. There's water in a tank and it's going out. So 1,000 has to be lower. And if it's higher, you're in trouble. You did something wrong. Yeah? Cool. Sorry, 160 point? Oh, well, that's boring. Okay. Why am I labeling it with gallons? It said gallons. If they told me to talk about this, I could be like, oh, okay, well, over the 30 minutes, the volume of the water in the tank went down to 160 gallons because a lot drained out. The end. But we're done. What did I just expose you to? We can use integration for things that aren't just position, velocity, and acceleration. Why? Because it's still movement. Ooh! Population in Juneau. This is fun. Let's talk about Alaska. Sarah Palin. No, just Alaska. Suppose that the population in Juneau in 1970 was 125 in thousands. Is that important? And that its rate of growth, T years, okay, I guess that's a label. P prime, they gave, oh. You think maybe when we're doing AP stuff, it could be really, really helpful to, like, you know, pull out really important information when you're reading it? Yeah? Now, you might develop your own marking system as we go. But hold on, do you guys see all they want is an at? And they already told us use P prime. Well, P prime, I'm pretty sure that I'm doing some sort of P prime in an integral because they asked for just population in 1990. Now, we do have to think about what we're measuring years in. Like, am I going to put 1,990? No, because they say 1970 and then they say T years later. So question, between 1990 and 1970, how many years later was it? 20. So wait, how many years later was 1970 from 1970 in 1970? 0. It was year 0. Is that literally all we have to do? Wait. Are we going to plug in 125,000? No. Why not? Thousands is a unit. Where are we going to go to solve? Our calculator. How are we going to write this integral with every stinking little piece? Parentheses, the dt, the bounds? Why? What do we not want them to do? Be like, oh, they had the idea, but they don't know how to write integrals. Let's take off points. Cool? What would you do? Go to your calculator, solve for a decimal answer, and answer the population with the label of thousands. Cool, kids. What do I want you starting to do? Play with the packet. When's it not due till? Monday. What are we going to be doing tomorrow? Problems together. Maybe starting backwards. Bye, cool kids. See you later. Alligators after wild crocodiles.